In this problem, we are going to convert cylindrical coordinates 4, pi over 3, 4 to rectangular and spherical coordinates. A quick recap on the three types of coordinates. Rectangular coordinates are in the form of x, y, and z in the 3D coordinate plane with the x-axis, y-axis, and z-axis. They describe the location of a point in space by 3 axes. The second kind of coordinate is cylindrical coordinates. In cylindrical coordinates, the x and y coordinates are replaced by the r and theta coordinates, such that the point in the Cartesian plane with rectangular coordinates x and y has the polar coordinates of r and theta. So, x and y becomes r and theta. If you want to know how to convert from x and y to r and theta, you can check out my video about converting rectangular coordinates to polar coordinates. A quick recap of the conversion factor is x equals to r cosine theta and y equals to r times sine of theta. And then the third cylindrical coordinate is the same z-coordinate as the rectangular coordinates. So there's still a z-axis. So relating the cylindrical r and theta coordinates to rectangular coordinates in 3 dimensions is the same as relating polar coordinates r and theta to rectangular coordinates x, y in 2 dimensions. From the xy becomes the polar coordinates. However, cylindrical coordinates aren't a natural analog to polar coordinates. When it's expressed in polar coordinates, the absolute value of the r coordinate is the distance from the point to the origin. But in cylindrical coordinates, the r coordinate gives the distance from the point to the z-axis, not the origin. A more natural analog in 3 dimensions to polar coordinates of 2 dimensions start with letting the first coordinate represent the distance from the origin to the point. These are known as spherical coordinates. So the first spherical coordinate is known as rho, which is the Greek alphabet. And then the second coordinate is known as phi, which is also Greek alphabet. And then the middle coordinate is still theta. So it will be rho, theta, and phi. Then we also have a conversion factor from the cylindrical coordinates to spherical coordinates. So after converting cylindrical coordinates to rectangular coordinates, we can use a conversion factor to convert rectangular to spherical. So from rectangular to spherical, it will be z equals to rho times cosine of phi. And then we can find the other coordinates from there. First, we convert to rectangular coordinates. So x equals to r cosine theta, which equals to 4 times cosine of pi over 3. Pi over 3 equals to 60 degrees. Pi over 3 radians. So this will equal to 2 after simplification, because cosine of 60 degrees is 1/2. Then y equals to r times sine of theta, so equal to 4 times sine of pi over 3. So then it will equal to 2 square root 3. The z-coordinate is the same rectangular and polar coordinates, so this will become from 4 pi over 3 forward, it will become 2 square root 3, 4 in rectangular coordinates. Turning to spherical coordinates, the data coordinate is the same in both cylindrical and spherical coordinates. We can use the rectangular coordinates to find that phi, well, the conversion factor from x, y, and z to phi is that equal to x squared plus y squared plus z squared. And this will equal to square root of 4 plus 12 plus 16. So it will equal to 4 square root of 2. Finally, since z equals to 5 times cosine, well, since z equals to rho times cosine of phi, so you have the cosine of phi equals to the z-coordinate divided by rho. So this will equal to 1 over square root 2, which is square root 2 over 2. So you'll get that phi will equal to pi over 4, which is 45 degrees. So the spherical coordinates will be 4 square root 2, pi over 3, and pi over 4. And that is how you convert cylindrical coordinates to rectangular and spherical coordinates.